Hello, Earthlings. We meet again. I hope you have been thinking about the importance of the dark matter in stabilizing the universe and making all existence possible. Today, I am here to reveal the secrets of the life of the universe itself. How the universe was born. Is the universe going to live forever or die? Ignorant as we humans are, many of you used to think that the universe is static, a place which always existed and will keep existing forever. About 100 years ago, astronomer Edwin Hubble, using a 100-inch telescope, measured the speed of the galaxies and proved that they are all moving away from each other. Further, the galaxy, faster it is moving away from its neighbors. Since everything is moving away from each other, if you turn the clock back, everything must be all together at a single point, at the beginning of the time. The whole universe, the space-time, exploded into existence from a huge explosion, the Big Bang. Where and when did the Big Bang happen, you ask? It happened everywhere. About 13 billion years ago, there was no space before Big Bang. There is no center of this expansion. As the universe expanded, things cooled down and gravitational force clumped matter together to form galaxies, stars, planets like your Earth, and eventually the life like you humans to observe it all. The expansion of the universe can be thought of as a rising loaf of a raisin bread. The raisins in the bread are the galaxies, and the loaf is the universe. The universe expands, and as a result, galaxies move away from each other like raisins in a rising raisin bread. Now, imagine throwing a ball upwards in the sky. It should slow down, stop, and eventually fall back because of the gravitational pull of the Earth. Similarly, the expanding universe, due to the gravitational pull of the matter inside it, should slow down, stop, and eventually collapse, ending in the Big Crunch, the opposite of the Big Bang. Is Big Crunch the fate of the universe? Is it going to die? In 1998, a team of scientists found a result which changed our present understanding of the universe. They studied supernovae, dying stars which explode like powerful thermonuclear bombs and emit huge amount of light. In the weeks the star explodes, it may shine brighter than the whole galaxy and act as a standard candle for us to measure the distance. It's like having a known 100-watt bulb. Further it is, weaker its brightness. So from its brightness, you can figure out its distance. However, bear in mind that the universe is expanding. When comparing distances on the scale of the universe, one should filter out the effects of the expansion. This can be done by setting the scale factor of the universe to be unity today and talk about distances today. You may ask, but what about a day later, tomorrow? Would the distance not change due to the expansion? Your tiny human lifespan is nothing compared to the cosmic time scales, so it introduces negligible error. You know that the universe is expanding thanks to Hubble and others. When light reaches us from such far, far away supernovae, the light gets stretched due to the expansion of the universe. This stretching of light can be measured and is called the redshift. Hence, measuring the redshift of a supernova can tell us how much the universe has expanded in the time it took for the light to reach us from that supernova. The brightness of a supernova or standard candle is a measure of its distance today. The distance today is a net effect of expansion in the past. If the expansion of the universe is accelerating today, then it was slower in the past when the light started traveling from the supernova. Hence, from past time to present, to accumulate a given redshift with slower expansion, the distance today of the supernova must be more than in the case of a decelerated expansion. In the case of a decelerating expansion today, expansion was faster when the light left the supernova. Hence, to accumulate the same redshift, the distance today of the supernova must be less than in the case of accelerating expansion. The data taken by a team of scientists shows that the supernovae for high redshift are much weaker in brightness than they should be for a slowing down universe. Hence, the conclusion is inescapable. The expansion of universe is accelerating. Now you know that the universe is expanding and expanding faster and faster as time goes on, defying the pull of gravity of the matter of the universe. What causes this accelerated expansion? The dark energy. No one currently knows what it is, but there are speculations, some better than others. Einstein's theory allows for energy to be associated with space. This is called cosmological constant, though it may or may not be a constant as our understanding develops. This theory of gravity by Einstein tells us that as space falls out while expansion, the associated energy due to a cosmological constant also keeps growing and the universe keeps on expanding at a faster and faster rate. Some scientists have proposed an energy fluid called quintessence, which keeps powering up this expansion. It is the dark energy which will save the universe from the fate of the Big Crunch, and instead, eventually all matter will evaporate and ionize into its elementary particles like electrons, protons, and neutrons. The universe will end in a big rip.
Hold your ship, alien. The dark energy is yet not well understood. If it changes its behavior in future, the universe will end up in the Big Crunch, and from its ashes, a new universe will begin. The Big Bang will follow the Big Crunch. The Big Crunch has not been ruled out conclusively from the data.
You puny humans don't understand the way of the dark energy. What are these black, small, flying ships? Are they some kind of drones?
Ah, the Batman. Never let dark villains enjoy a fun conversation. Be glad, Vader, that this bag does not have a spaceship now. Else, the villain in the whole universe would be in constant depression.
Will you stop predicting doomsday and stop creating panic? The universe does not
care about your belief. It runs on the laws of physics. Science is always humble, and as new facts and theories emerge, the understanding changes. The theory of gravity is not complete. It does not work at atomic scales. So, our best theories, the quantum theory at atomic scales and the gravitational theory at larger scales, are not compatible. We need to be hopeful, to work hard, and understand this puzzle. We don't need your doomsday predictions. It's a work in progress, and importance should be more at data collection from observation and more work in theory rather than armchair speculation.